I have no problem with that at all.
So my name is John Watson, and this is SNHU's Computer Science 260 Data Structures and Algorithms course, and we're doing a live meeting for the class. This is intended to go over week 2, which is the second half of the getting up to speed on C++. And so the goal here is to be able to walk through what we went over last week, answer any questions if you had difficulties, kind of show it if you maybe you picked up some tricks that you didn't know before. But anyways, that's the goal, is to be able to go through all of this. If we go to learning modules and go down to module 2, the primary assignment here was this up to speed activity, and it includes lab files. If we download, actually I already downloaded the lab files. If we look at them in this format that you're seeing here, you'll see repeated over and over and over. What we've got here is a set of files, a starter program, as well as some instructions. I'm going to go ahead and extract this. Because we're going to look at it in a minute. So the first thing you want to do when you're looking at these assignments is to open up the document so that you can see what the instructions are. And you'll notice this format we're going to use, as I said, throughout the labs in the course. So there's a familiarity and a commonality to it. Although we'll be studying different types of algorithms and data structures, we're going to use the same format. And the primary source of data is going to be these online auction bids files. These are CSV comma separated value files. And we actually provide 2 files in there, one which contains just December 2016 bids, which notice it's only 18K, and a larger file which is 2.8 megabytes. So the difference is a small test set of 179 bids and a much larger set of 17,000, almost 18,000 bids. So we're going to use this format, as I said, throughout the course where we're processing this data. And the way in which these labs all begin are we start up Eclipse, which if you haven't already done so. And I'm going to point out the workspace for a minute. So basically, with Eclipse and actually with quite a few of the integrated development environments, or IDEs, they all work pretty much the same way. You have a main folder, and underneath you have subfolders or directories, one for each project. And you notice we have, where we left off last week, we have lab 1.2. And so the instructions say start by creating a new project, lab 2.2. So we'll go ahead and do that. I can just right click here and say new. Make sure you choose C++ project. We'll call it lab 2-2. Oops. And you, for this course, and to keep things as simple as possible, always select the Hello World C++ project, and make sure you check or select the box for your MinGW compiler. Once you've done this, you can fill this out if you want. It's not necessary. The reason we choose the Hello World is because it sets up a whole bunch of settings for us. And it starts with a simple shell program. It's pretty easy. Now, one of the things we said, and this is going to be the case from week 2 onwards, is that we're going to be using some of the newer C++ features from C++ version 2011, or we just call it C++ 11. Now, Eclipse CDT starts with, I believe it's 98, which is a much older version of C++. And so that's the default, that's the standard, that's the baseline, if you will, as far as C++ compiling goes. So with these projects, what you want to do is after you create a project, you want to come over here, and I'm going to go ahead and copy this string. Once you've created your project, right-click on it, go to Properties, and you choose C++ Build, and then Settings. And then here you're going to go for the GCC C++ compiler. And on the miscellaneous section, you're going to basically paste that thing, that string. So these are flags that are passed to the compiler when it runs to control what it does. And what we're going to see here is we're saying that the standard C++ version we're using is C++11. And that's going to be important, as I said, because some of the features that we're using, especially with algorithms and data structures, requires this. Now that we've done this, I just want to show you proof that it's working. I can go ahead and click this little tool hammer. I could also choose project, build. You can even go over here, and these two buttons, there's a debug and a run. So the first thing I'm going to do is say, or you can also right click here and say build. So when you do this, it's going to take the source code, compile it, and the first thing you'll notice, and I'm going to go down here to my Windows Explorer, and I'm going to right click and open a new one. So I can leave that up there on the downloads. I'm going to go here. I put my workspace on the D drive, CDT, and you notice that project folder, that project in Eclipse creates a folder on the hard drive. And you'll notice there's some settings here. These files, they look kind of funny. They begin with a dot. That's actually a Linux Unix standard for what's called a hidden file. But you'll notice there's a source folder. There's the C++ program that we see here, which is just a standard little hello world template. By the way, when you're doing your assignments, when you're finished with your assignment and you're ready to turn it in, the only thing you really need to turn in is this lab.cpp file. There's no reason to zip up the whole folder or create the, eBids files, none of those things. The only thing I'm interested in is the C++ code. And as I said, we keep these very simple.
Professor, sorry to butt in for a second, but Danielle and I aren't seeing anything at the moment. Are you sharing your screen?
Gosh, I am terribly sorry.
I do it about twice a day at work, so don't worry about it. There you go. Awesome. Thank you.
Quick backup. So we downloaded the program, or downloaded the zip file. I've expanded it. Here's the files we're looking at. Here is the instructions that are contained in the zip. So they're not in Blackboard per se. They're all self-contained in the zip file that you download for each assignment. And so what I do is I launched Eclipse, and I'll go through and do it again, but not save it. You can right-click and say New C++ Project, and then give it a name. So I'm going to call it actually Lab 2-2A, just so we can walk through it. Make sure you always choose Hello World, and that's a standard simple template for a C++ project. And make sure you choose the compiler. If you don't do this, you could go back and set it, but it forces you to kind of go in and have to monkey around with the properties files, which are not a lot of fun if you're trying to just focus on getting your work done. Eclipse is one of these tools that's very powerful. There's a lot of functionality in there. There's a ton of toolbar buttons. There's a ton of menu options. In fact, that's only just the start of it, because Eclipse comes with what's called plugins. So you can include a whole bunch of additional features above and beyond the basic Eclipse editor. So there's a ton of stuff in there. You don't want to focus on that too much. So we tried to keep it channeled so that, we use a Hello World project. You set a couple of settings, and then you're off and focusing on the work you're doing. And so what I was showing is, here in the Project Explorer, you see the folder, you see the files, and so on, and then you can see the directories on your hard drive. So here I've just created a second one, Lab 2A. Now I'm going to go over here and delete it. I'm going to right-click, choose Delete. Now I can say just delete it and click OK, and it removes it from here, but the files remain on disk. Or I can check the box and say get rid of the files on disk. Now I don't need this Lab 2A because I was just a repeat. When I do that, voila, it's gone, it's cleaned up, it's missing. So back to where we were. After you create the project, you want to make sure, and the instructions show it here in the setup, you want to copy this string for the compiler settings. And this is telling Eclipse, or actually the GNU compiler, that you want to use C++ Standard 11. Go to the C++ build folder, choose settings, on this tool settings tab, you choose miscellaneous under the compiler, and then you just simply paste this string in. And what that does is tell the compiler that you plan on writing code that complies with the C++ 2011 standard. If you forget to do this, you're going to get some errors when you start to import our code, as I'm about to do in a moment, because it doesn't, the default is C++ 98, which is really very old and very basic and doesn't support all the features that we're looking for. Once you finish this, you can go ahead and click, for example, the hammer. You can right-click and choose Build here. You can choose it off the project menu, and you can even choose it up here. So actually, those are run settings. Once that's finished, I can choose this little run. You can do it here as well. You could say run as, and I'm going to say local C++ application. So now that it's been compiled, and by the way, before I do that, if we go back and look at this folder here, go into Lab 2.2, there's the source folder, and there's also this debug folder. The debug folder is where it puts the debug output, which I'll get to later on. But there's actually the program that was created. And we're going to go ahead and run that. So you can do it from the menu. I happen to like to use the toolbar. So I'm going to say run as local C++ app, and it runs, and it finishes and ends. And notice it says terminated right here. So that means the program ran and it's finished, no longer running. And all it does is output to the console hello world with exclamations around it. So that shows me that we've got a properly configured, go ahead and close this, a properly configured project, and we're ready to go. So the next thing we want to do is, after you've set up this empty project, and if you do compile it, you do something called clean. And when you do this, I'm going to go back and look and show you what happens. Building means taking the source code and compiling it into machine code. And you notice that the clean does this. It removes the temporary files, and now this executable is gone. That's just an empty folder. So that's what it means to clean a project. And this is something you're going to do fairly often in Eclipse. So now that we've cleaned it, and again, it's only because I was playing around, the instructions tell you to take our lab 2.1. Oops, I did 2.1. That's interesting. Well, we'll leave it at 2.2. So I'm going to rename this lab 2.2. The actual name isn't that important. And I'm going to copy this, just copy, into the Eclipse directory, replacing the standard default one. Now remember, the default one just says hello world. When we go ahead and paste this in and replace it, now I like to do a refresh here to make sure it rereads everything. When we open this, you can see that it's quite a lot different, and it's got a whole bunch of boilerplate code, just like it did for the last assignment, and you'll find the same thing for every assignment. And the way that we do our assignments, and I think if I remember correctly, these are the last two that are done specifically this way. We've put markers in there. So one of the first things we do, these markers tell you where you need to put some information or replace them. But if you follow through these tasks, and what we did was we included, so there's a task that says reference the C++ library, and you notice there's this little thing that says fix me. Here's something cute about Eclipse. If I click the tasks tab, here's all the fix me's. So that's kind of neat. It shows you, you can actually quickly jump to a particular piece of code. And programmers do this quite a bit. They may put a marker in here. They may see to do or fix me or something, and it's just a comment, but if it begins with these uppercase letters, or some set of uppercase letters like this, I think fix me or to do is another one, then Eclipse recognizes when it scans the source and it puts them up. So you got a little task or a to-do list. So this is actually functioning as a list of things that you need to do, and these fix me's correspond to the various tasks you have to do here. So the first thing that we say is we have to reference something called the CSV parser library. So before we do that, we go back here. Remember I said we've got these two CSV comma separated value files, and here's the December one. You notice it's just a list of articles to be bid upon, or that actually were bid upon, And there's the way that comma separated values work are you can have a top line be a heading line, which is really kind of like a field. So there's article title, article ID, close date, so on and so forth. And there's a bunch of rows of data. So the exercise that we're going to do is to read this file and store it in a data structure called a vector. Now, rather than going through all the kind of drudgery of doing basic file I/O and streams, which are interesting maybe the first time you do it, but about the first or second time you've done it, you probably never want to do them again because it's really very tedious. Instead, what we did was we found a library from, and I think it does mention here. Well, it mentions it in the. I think we talked about a little in the primer that comes with the course. If we go down a little further. Here, we provide a library that is open source. You can actually click this link and it'll take you out to GitHub, where the source code is. You could even examine the source code. Now, we've pulled down the pieces of source. And there's some instructions about it. It says what is a CSV file. It tells you how to compile this if you want to compile it yourself, and some usage examples. And you can see some examples of how it's used. We're going to use this program or this library in our assignment. So in order to do that, first thing we need to do, if I go back to here, is we need to import it or bring it in. Now, if we go here and look at our tasks, it says reference the CSV parser library. So in order to reference it, it's pretty easy, pretty straightforward. Oh, one thing I forgot. Not only do we need to copy the lab program, but we need to copy these two CSV parser files. So we'll go ahead and copy, paste them into the Eclipse workspace directory. And notice, even though I pasted those files, they don't appear here. This is where you want to do a refresh. If you right-click on your project, choose refresh, voila, there they are. So let's take a moment and take a look at what we've got. There are actually two files here. One's ending with CPP and one's ending with HPP. These are a common extension or a common approach to source files that started way back, gosh, in probably the 80s with the C language. And the idea is that CPP files are the actual C++ code. So there's all the raw code. You can see it if you're into it. There's a lot going on, but this is all the code and logic that goes into reading and parsing a comma-separated file and bringing it into memory so you can use it. And I think you can see why we say it's really not a good idea to want to spend a lot of time doing this, because there's a lot of drudgery to it. But this is the CPP file. And then there's an HPP file, which is called a header. And in here, what you find in the header are a list of definitions. So they use a namespace called CSV, which I'll show you in a moment. You can see there's a class called error. There's another class called row. It's got something called a constructor, which we'll look at, I think, a little bit. And there's some public methods. There's one called size, which takes nothing for parameter, and it returns an unsigned integer. There's another method called push, and it takes a string and returns nothing else. So the string is being pushed somewhere. There's a set method, which takes two strings. But notice this HPP file, this header file, doesn't have what we call an implementation in most cases. There's some tricks you can do that I don't really want to get into. It's advanced C++. But in essence, the header file contains all the definitions of what is in your library, what you can use in the library. So there's a class called parser, and there's a get row, row count, column count, get header element, delete row, add row. So all of these things, all of these methods are in there. They're just defined here in the header. The CPP file actually contains the code, the logic for every one of those, for every entry you find here in the header. So let's just take, for example, delete row. I'm going to copy that string, and I'll just do a simple search for delete row, and there is the code for the delete row method. It takes a position, and there's some code there that checks size, and it does a delete and blah, 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 blah. So anyways, that's what represents the CSV parser library. In order to use it in our code, we need to include it. And it's very similar to the ones we're doing here. So we could do pound include, if I can type correctly. And then the difference is I'm using quotes, not the angle brackets. And CSV parser dot, and I'm going to show you something, CPP. The angle brackets syntax is reserved for what's called system libraries. These are included as part of the C++ runtime. If you have any user-defined or non-standard C++ libraries, then you typically include them with quotes around them. So now that I've included this, what I've done is basically, what that's really going to do is cause it to open up the source file, read in all the definitions as though I had written the code. So this is a way in which we can use and access a library of features and functions that we haven't written. Now, having done that, I'm going to save. Then I'm going to try compiling. And we should see here on the console, you get an error. By the way, notice that little dash standard 11. So this is actually the compiler command that's being done from a command line. So Eclipse is basically taking all these project settings and using it to invoke or drive the C++ compiler. And I just wanted to point out that you can see that extra setting. If I took that off of the miscellaneous tab here, properties, C++ build, settings, tool settings, miscellaneous, if I remove that, it won't have this switch and it won't use the C++ 11 features. But notice I've got an error and it says unexpected qualified ID, blah, blah, blah. Oh, so actually it's complaining about this other stuff. I intentionally did this on purpose. I included the CPP file. This is a common mistake that people make. You do not want to include the CPP file. Typically the way these things work are the header file contains the definitions, if you will, and then this contains the detail, or what we like to call the implementation. So this just defines what CSV parser has for methods. This has the implementation of all of this stuff. But notice up at the top of the CPP file, they are including the HPP. So if we're including it and we include this and then this gets included, it gets confusing. The way when a library is presented to you or given to you, or you download something and you've got header and C++ source files, you always reference the header. And the reason we do this is, the reason the developer did this is so that others can use it, because he made it into a library. We could have eliminated the HPP file. We do that with our lab activities because we're not planning on publishing a library of features and functionality. We're just creating programs ourselves to test things. And so what you do is you include the HPP file, and that will cause the compiler to go out and read, find these definitions, and use them when we're looking for, or when we're in our code when it's looking for stuff. So I'm going to change this to HPP. Let's take a step back for a minute. And so now we've referenced it, and we need to define a vector data structure. And we can either go searching around, or we could use this handy dandy little thing. And we already got the bid stuff. Define a vector data structure, and that one's missing, but here's a place for you to put it in. And if you remember in our Zybooks code, or our Zybooks text, we go to vectors. You can see vector, data type, and then the name, and sometimes the number of elements. So let's go ahead and see if we can clean this up. This is actually what was causing the compiler error, because that's not legal, valid C. That's why you're seeing these errors here. Let's start with this, and then I'll go back a line. So we're going to say, oops, vector. And we're going to call this, I don't know, let's say a vector of bids. and might as well give the variable name bids. So now that we've done that, now notice here in the comments, it says load a CSV file containing bids into a container. Now that container happens to be a vector. And we take one parameter, which is the path to the CSV file, and we return a container holding all the bids. So the idea is that we've got this vector we've defined called bid. We're now going to use that as a return value as well. So on my definition, I want to copy this, and that's the value that's being returned. Notice as I start to fill in the things and correct stuff, things go away. And we're going to return that variable name, which is bid. So I can copy this, paste it here. And if I save it, we're doing a little bit better. The reason it's still reporting this error is because it's using the output of the last compile. So let's try compiling. A lot of times after you make some code changes, you want to save it and compile it, and you see the error disappears. So already our code is getting a little cleaner and ready to run. So we've taken care of that, and let's go back to our instructions. Define a vector, task 3. Each bid read from the input file must be stored in a bid structure. Okay, let's take a look at this. Right here inside the for loop. So we've got a loop to read rows of a CSV file. And there's a basic old for loop with an integer counter I that's set to 0. And we've already put the boilerplate code in. So this is basically code that's going to use that CSV parser library. We're going to create an instance of it, and we're going to give it the path of the file, the CSV file, and it's going to be stored in a variable we call file. Now, we could have called this foo or cat or mouse or whatever we want, but we chose to call it file because it seemed to make the most sense that this variable represents the CSV file that we're processing. We go back here and look at the parser class. Class in here. The separator. Let's see what it was here. Parser file. I'm looking at the GitHub documentation, and it gives you an example. It shows you create an instance of it, give it the path to the file, and it's stored as file. And then you can see, and here's their example: year, make, and model, 1997 40, 350, 2000 Mercury Cougar. And so if you create this CSV parser file using this file name, it's going to open this file, read it, and store it in a variable called file. And basically, it's going to give you back rows and columns that very much mimic what we see, for example, here. Careful, because we're programmers, we like to do things different. One of the things that we do is what we call zero-based arrays. So row 1, the first row of data, is actually 0, not 1. These are what we call zero-based. I think a couple people made that error. So in order to use this, what we need to do is something like, so we'll just leave that fix me there for now. And there's 2 ways to do it, and I actually describe that here in, let's go back up to the, maybe I didn't. I know I sent the notes to some people. There's 2 ways to use a vector. Now, the way that the book shows, which it's okay, but I don't totally agree with it, is in their example, they've got this definition where they also include not only the variable name, the identifier, but they have the size or the number of elements in parentheses. That's one way to use a vector. When you do this way, When you do it this way, you're going to find it's fixed at 3, and you can reference these very much like you would arrays. So this is why we have this section that compares arrays to vectors. Arrays are very simple, but they're also very much prone to errors, and vectors are created as an improved array that's a lot more type safe and will give you appropriate error messages and prevent programs from crashing. So one way to do it is to size it. In this case, there's 3 elements. Notice their indexes are 0, 1, and 2. The other way to do it is to specify a size. And if you do not specify a size, then you have to use a different method. And I think, where was it? Might be in the next chapter. Might be here. I won't waste a lot of time. Basically, you can specify a size, or vectors have a method called pushback. Pushback is basically a way to push things onto the end. And I'm going to use that method first. So I'm going to create a vector of bid structures called bids. And then here, I need to create a separate bid instance. So I'm going to call it bid. This is what's called a local variable. It's known inside of this for loop because that's where the definition is, called bid. And then with that struct, I can then do things like bid dot. And as soon as I start typing, notice because the bid structure was defined for you, Eclipse knows and pulls up these things. And I can say title, and using this structure here, notice that 0 displays 0, 0 actually displays the first row, first column, 1. You can also specify it with strings if you want, instead of just variables. So if we look at our CSV file, the title is stored in the first column, which, remember in programming, that would be column 0. So I'm going to say file. Now for the row number, I'll come back to that in a second, comma, 0, and a semicolon. So we've already got a for loop, and this for loop is iterating over the row count, which is the number of rows that were read into this file structure, this parsed file structure. So in essence, once we've processed or created the file, loaded it into memory, sucked it up, if you will, now we can create a for loop and iterate or loop over every row in this file and store it in our vector. So we create a temporary bid variable. We assign the title, and the same logic goes all the way down. I could do bid dot fund equals file sub I, which is whatever row we're currently processing. And I'll come back to that in a minute. Now, where is the fund? Remember that we're 0 based, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So it should be column 8. And then we have, what else do we have? Bid dot, there's an amount, which is a double. This is where we have to use the technique that we did last week, which is we have a method that we provided for you called string to double. I'm going to copy it because I'm a lazy programmer, and that way I don't mistype it. And if we remember from last week, I believe we had this here. Let's just take a quick peek. Right here, string to double, you can pass it an amount or a value. And so in essence, this is doing what we did last week with our bid structure. In fact, I'll be even lazier, and I'll just copy, let's just copy this whole thing from last week's program. We'll go here, and we'll say string to double. Of course, when I paste it, it's not going to know what string amount is. Oops, just realized I have this typo here. And I'm going to replace amount with, where do we say the amount is? 0, 1, 2, 0, 1, 2, 3, 4, 4. So I'm going to say file sub I sub 4. Now that we've got our bid amount created, and I'm going to show you actually, and this is the magic of having multiple screens. I'm going to actually include a little bit of test or debug code. Sorry, didn't quite get my copy to work. What I'm going to do is paste. So there's a little output statement similar to what we used in last week's thing that will actually print out or dump if you'd rather. Let's see, we got item. I called it item. Let's call it title. Title, fund, amount. So this will display to the console this bid structure that we just created. And this can be very helpful when you're debugging. Later on, we can go ahead and comment that out if we don't need it. And now that I've got this bid defined, I need to put it on the, or into the vector. Remember, our vector is called bids. So I do bids dot, and you get to see all the methods of the vector here in Eclipse. And one of the methods is called pushback. Here's what's really cool and amazing if you think about this. Because I've defined the vector as having type bid here, Eclipse is analyzing this and it's showing you the bid structure that we're using. So it's already picked up the fact that we're using a vector full of bids. So I could say pushback and give it the bid that we just created. Boom. I go ahead and save this. Let's try compiling it and see if there's any errors here. There's a warning, but we could change this to unsigned in if we want. Unsigned. Actually, before I do that, I'll show you something else too. Eclipse is really cool because you can click, sometimes you can click, where is it? I remember, where's Quick Fix, there we go. Doesn't have it this time. What it's complaining about is the fact that this row count is an unsigned integer and we created just an int. If I do unsigned int, because the counter does not have any sign to it, should clean it up. Maybe we need to compile it. There, that's gone away. And if you haven't seen this already, you notice here on the right edge of Eclipse, you've got all these little markers. So there's some blue markers for fix me's. There's red where you've got some problems. And there's this summary up top which tells you there are 17 errors. I can also jump ahead and find the errors, but I want to go back to the instructions. We've done this, we've done the load the bids. Oh, we need to complete the method call. So let's say, where's this complete method call? 5. And so for that, we're going to want to, I'm going to do this very quickly. Boop, 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 bid. Case 2 is display bid. Oops, gosh, wrong program. And that explains why there's 2. I'm going to go ahead and close this for now. This is another little trick. Because there's 2 programs that have fixed me's, that's why you're seeing double entries here. What you can do with a project is you can close it, which basically is a way of putting it on the shelf. You'll see it collapse and you can't go into it anymore. And it's still there. It's still available if you want to open it back up and use it again. But notice as soon as I closed it, put it away, all these duplicate fix me's went away because now I'm looking at just the fix me entries for the program that we're working on. And we've got menu option 1 is enter a bid, 2 is load bids. So we're going to need to call our function here, load bids. And in order to do that, we need, actually what we need is really the same thing. So let's call it, oops, and I'll just go ahead and type it. Define a vector to hold all the bids. And I'll explain this in a moment. Vector, bid, and we'll call it the bids. And this timer variable we mentioned, it's in the instructions, excuse me, in the primer. We show you some code here for measuring elapsed time, because part of our working with algorithms and data structures is we want to be able to measure and include some code that will allow us to measure the amount of time it takes. So we'll go back up to the top, and we've already got the time include here. So we'll go down to here and back to here, and we can just literally copy these two lines. Actually, that line goes inside of here. Initialize the timer variable. Boom. Complete the method call to load bids. So we called our variable the bids. So we're going to say the bids equals, oops, load bids, open paren, and our load bids method. By the way, if you're scrolling around a lot, you can also collapse things just to make it a little easier to find and kind of hide the stuff that's not important. We're going to need a CSV path, which we created here. If I compile, let's save it. And I compile it, we're getting better. We still have some problems. Let's see. Oops, I got my semicolon. Here's another trick, by the way. Let's say I want to work on this, and I've just finished coding the load routine, and I'm not really at the moment interested in the final output stuff. The other thing we could do is you can highlight this code, and let's see if I can find it on the menu. Surround with. Nope. What the heck is it? Too many editors, too many things. I know there's I think, I could be wrong, I think it's Control/. Excellent. So if I highlight lines of code, I can press Control/ and it toggles putting comments on all the lines. It saves you from typing it over and over and over. So what I've effectively done is comment out these lines that are in errors. So this is just a temporary thing. I'm going to save it. Even though this looks really bad, when I compile it, if I've done everything correctly, you notice, voila, there are no more errors. So this program could actually run. One more thing to make it run is it's going to look for the file in the local directory where the program is. So I'm just going to go ahead and do this now before I forget. I'm going to copy these two files here, and let's just go ahead and run it. See what happens. And you can see there's the menu that's displayed. I'm going to choose 2, and let's see if it blows up or not. Now it flashed by really, really fast. If we go back and look, as soon as I type 2, it came into this case statement, and we'll fix this up. I actually forgot to put the clock timer at the end. It invoked load bids, giving it the path. So we came up to here. We constructed a vector. We loaded the CSV file. We zipped through the 179 rows, and while we were constructing a bid and storing the values from the file into it, we output the information, and then we stored it on the vector. Then we return the vector to whomever's calling it. So the only thing I missed there was, and let's go back and do this. Primer. Yeah, we're going to take these lines of code, copy them, and paste it in down below, because I want to see the result of this work. Save it. I like to put a blank line to separate the break. I'm going to recompile it. Oh, it's still running. So the other thing we could do is you could do a clean. It's still there. Sometimes what happens is, so we were running it and then we stopped. It should have, actually the console is still running. What happened was I forgot and left the program running. Another way to do it would be to, I believe, I go in here and say delete. It won't let me delete it because it's running again. There's a lot of different ways to do it. I could get fancy, but what I'm going to do is probably the simplest thing, which is get out of Eclipse. Now that Eclipse is not running, let's see if I can delete this file, because I really want to rebuild it, and that worked. So we'll go back into Eclipse. And let's make sure we're doing things right. We'll go ahead, build this guy again. The build was successful. Come on. Now you can do the running and the testing here in Eclipse, but just to show you, here in this debug folder directory, what I'm going to do is go off-road a little bit. And I'm going to open the PowerShell prompt, navigate to the D folder, and I think it's what, workspace, CDT, lab 2 something, and then we'll do that. And there's that debug folder. I'm going to change to the debug directory, and there's the compiled program, and there's the data files. So rather than running this in Eclipse, I want to test it here from the command line. So I can just like lab22, and I hit enter, and you're seeing the same thing you would see in the console window in Eclipse, only now I'm going to choose load bids and watch it rip. Now, same behavior we saw there. It loaded and processed every one of the values, but then notice too, we can see some timing, and it said it was 399 milliseconds or 0.399. Now, one of the ways, I'm going to go ahead and exit now. Make sure we exit out of the program. One of the things that we can do, and the way that this program is set up, we set it up for you, is you can pass arguments on the command line. That's what this stuff is from this main method. All C programs have a main method. That's how you start a C++ program. It's not something, you don't have a choice in that. If you create a C++ application, it's going to have a main method somewhere, or it won't run. So in the main method, you also get the option of passing arguments on the command line, and that's what this is. And here we've got a thing where if you pass, we basically built this program to facilitate testing. You can pass the path to the file to be processed. So I'm going to run this again. And I'm going to put a space, and I'm going to do ebid. And instead of the one for December 86, I'm going to use monthly sales. That's the larger one. That's the one that's 2.8 megabytes and has almost 18,000 records. When I ran the small one, it took basically little less, or 4/10 of a second to process. Now I'm going to run the big one, and you'll see that it's going a lot longer. It's loading all 18,000 records. Still loading, still loading. Eventually it'll get through there. I'm sure glad I don't have to type that. When it's finished, our code will report how long it took. So while this is running, or while this is going, I want to, I guess, open it up and say, does anybody have any questions? I know I kind of ran through a lot of stuff, and I will provide the recording afterwards. So it took 40 seconds. Now, part of that time, just to kind of show you the difference while we're doing this, I'm going to go into this program, make sure I exit out and don't leave it running. And I'm going to comment out our little debug code. So I don't want to display the output anymore. Now when I compile it, and then from a command line, you can always use the up arrow on your keyboard and bring back the last command. And so the only change I made was to not display to the screen what the bid was. And let's see how long that takes. Wow, look at that. Without stopping to display, it went from almost 42 seconds to 1/2 a second. So that just kind of shows you what kinds of things can happen with your programs and performance. And if we try the little one, oops, let's go to exit. And I want to do the one without it. Now that I've commented it out, I'm going to say load, and it took 4 milliseconds, 4/100ths of a second to hit 179 records. So, any questions?
I have questions, but my questions are more about this week's lesson. So I guess if anybody's got questions about last week's, like, I'll wait. But otherwise, I have questions, yeah, but not related to what you showed.
Anyone? Danielle? Joanne? No questions. They're waiting on you, Jake.
Okay, cool. Can I share my screen then?
Let me go ahead and, if we do that, yeah, let's go ahead and see. I've never tried that. Let's try it. See what happens.
Okay.
Do I need to stop sharing?
I'm not sure. Okay. So, are you seeing?
I am.
My SNHU or my code?
Your code.
Okay, cool. I've got 2 screens, so I just wanted to make sure it's the right one. So, I conceptually, I understand what we're doing in this week's lesson with creating a new data structure, specifically linked list, and going through and creating. So the way I understand it is that this here is like our public API, right? In other words, we've defined all of the different methods that we're going to use within this class. Yeah.
Correct. Let me just add as an aside to that. Now, we made this very simple. Normally, that public API would be in a separate HPP file, but
right,
you
exactly.
can put it together. Yeah.
That would be like the header file that we used for last week's. Yeah.
Yep.
Yep. Okay. So what I'm thinking about here is I was working in the book and found some code that was similar to this in order to initialize these housekeeping variables. And I understand what this is. So this one here is going to hold on to a value that's within a node. Yeah. And this is going to contain the next node pointer, so that if I append or if I delete something, I can save in the value there and point to the correct node when it's done. We've got this destructor down here, and I guess that conceptually I understand what a destructor is. It's a function or a method that's used to destroy that's used to remove the Well, it's used to free up memory by destroying the variables that were built in the constructor, right?
That's correct.
Okay, so
Not just a constructor, but it's not just a constructor. It's freeing any kind of memory or resources that you might have used while the class was up and running, whether you had that instance going. So it's just generally anything that you want to free up.
Okay, well, here's my question. I saw in the book it was saying that if you initialized a variable by using the new command, then you could use the delete command to in a destructor to free up that memory space.
Yeah.
But I'm not sure how we do it when we create the housekeeping variables in this way. Do we still use the delete command? And what exactly is it that I'm going to be deleting? Am I going to be deleting these variables or something else?
Okay, let's step back a little bit. So, as I mentioned in the notes, you've got the pointer to the next node,
Right.
which is basically the start of the list.
Right.
If that were created with a new instruction, which we're not doing,
right,
then you would have to destroy them. You'd actually have to loop through your list, removing every one of them to do it very cleanly and not leak memory.
Right.
And this gets into that little bit of thing where, you hear about programs that crash, or you hear about vulnerabilities and security things and how they learned how to break and hack into things. The vast majority of the code that gets broken into and hacked are C++ code, because it is very, very hard for humans, programmers, especially as we're doing all this work, to try to remember to clean up every little thing, to initialize our pointers correctly, do all of these things. So just so you know, that's where and why you can do a lot with C and C++, but it also is very difficult in some respects.
And in languages like Java, they have what's called garbage collection that takes care of that for you, right?
Correct.
Okay.
It's much harder to leak memory. Usually programmers can't leak memory. That's not to say that Java's never had a memory leak, but it happens inside the Java runtime. That's something that in this case Sun or Oracle would patch and send out. But it's very hard for you and I to leak memory in these managed libraries or managed language environments like Java and C#.
Okay, so what I did too is, I actually went through and I did a find through the code, and I only found the references to the linked list here in the public API and here in the destructor. So I guess I felt like the examples that were given in our book this week on destructors were kind of thin and not really sufficient for me to get a grasp on it. I'm not really sure what I'm supposed to do with the destructor, when I'm supposed to invoke it, or how it's supposed to work.
You don't need to invoke it, and you don't need to do anything. It's really just there as an empty method.
Oh, so I don't have to
because we're not using it. No. And notice there are no fix me's or to-dos in that section. Now, since you opened the door, I'm going to comment on the code that I'm looking at. Now, the original code had a default constructor with no parameters. You've gone and found some code in the book and you've initialized it. And you're passing two things in there. You're passing an integer, which is called init.
Yep.
And you've got a node pointer called next.
Right. Exactly.
So when you create a linked list, what is init and next going to be?
Init is going to be the actual value of the node. So let's say if I want to append the number 255 into the node, then init is going to be that number, and then the next node pointer is going to contain the next node pointer is going to contain the value of the next node in the list that it needs to point to.
Don't move your screen anywhere. Look down at the append method. That's right there near the bottom on line 82.
Yep.
So that's where you append a new bid to the linked list.
Right. And
you take in a bid structure. So you're starting to mix things up, and this this is very common. It happens, and it can be very frustrating. There was no need to change the default constructor.
Oh, really?
Because if you have a default constructor and you don't pass any arguments in, that first off, it's no longer default because you put arguments there. It's not what is known as the default constructor. The default constructor for a class is the name of the class with no arguments.
Okay.
So just as a matter of semantics and being correct, that is not a default constructor anymore because you put parameters there.
Now, so if I take out the parameters, is it still going to work?
Sure.
Okay. Okay.
So, and the thing about pointers, remember, is that until a pointer points to something, it is always best and safest to initialize it to null.
Oh, so I should initialize, so this data val, so this should be initialized to 0, I guess, and initialize this to null. Yeah?
Correct. Yep. That's what you want to do with pointers.
Okay. Can you explain why it's the best idea? Is that so that you never actually get it to accidentally point to something that doesn't exist?
Correct. It points to something that doesn't exist, and that's basically it's really the only way we have to know whether a pointer is pointing at something, right? Because basically a pointer is either going to be null or it's going to point somewhere.
Right.
And if it's pointing somewhere, you would expect to find something wherever it's pointing to. And so as a matter of practice and safe coding, you initialize your pointers to null. And actually, when you get into appending and moving things around, and especially in subsequent lessons in the coming weeks, when we're doing these things with pointers, you're going to be examining pointers. Like, what if we were to insert something in the middle? You know, you have to start to manipulate pointers and push things around.
Okay.
And so it's common practice, since the list is empty, a default constructor, there's nothing in it, the next pointer should be initialized to null. Now, again, you have to be a little careful because you borrowed code that's looking at ints. Our linked list is not going to store ints. Our linked list is intended to store bids.
Oh, right. I see what you're saying. Okay. I mean, I didn't get very far, so.
Sure. Well, this probably saved you at least some amount of time, whether it's minutes, half hours, hours of going down a rabbit hole you didn't need to go down. Oh no,
that's already happened. I spent a few hours trying to figure out what I was supposed to do with the destructor, and got a lot of definitions about what a destructor was and why it exists and all of this, and still couldn't quite figure out where I was supposed to fit it into my code. Especially because at this point in time, these labs, at least, they'll tell us to write a method or something, and later they'll at least tell us to call it, or it's already called somewhere else. And so since I didn't see it called anywhere else in the code, and there were no other references to it, I was really sort of thrown for a loop as to why it was there.
So let me make a generalized statement. Concentrate on the fix-me's.
Okay.
Because, again, this is C++ especially is a wide open language, and you can go so many different places with it. We tried to keep it focused so that you just concentrate on the things that are important for the lessons we're learning.
Sure, that makes sense. Cool. Okay. Well, I think that answers my questions for the night. I don't know about how everybody else on the call feels, but I actually love this course so far. I think it's a lot of fun.
Good.
Yep.
Hopefully it's challenging.
It is. It is. So far, it's been challenging, but fun. Okay.
So I guess if we have no other questions, then yeah, we'll say good night, and I'll post a link shortly with this recording for the slackers who couldn't be here.
All right. Nice to meet you, Professor.